another example of a power series to determine the interval and the radius of convergence, we have the series n equals 0 to infinity, 3xn raised to the n. In the previous problem, we had almost the same series, except we just had 3x. So now we're just throwing in an x on the inside of that to determine what the interval and radius of convergence are going to be. Once again, we can use the root test on this, all right, because we can take the nth root of whatever's going on inside of here. All right, so let's go ahead and do that. So we are going to take the limit as n approaches infinity of the nth root of the absolute value of 3xn raised to the n. Okay, and that has to be less than 1 for this to be convergent, okay, by the rules of the root test. Now, this n and this nth power are going to cancel out, so we have the limit as n approaches infinity of 3xn absolute less than 1. All right. Now, if we wanted to, we could divide everything by the 3 that's on the inside. There's a rule of absolute values that because this 3 is positive, we don't have to do anything with it except kind of factor it out. So keep in mind that rule of algebra. And what we could do is we could just divide by 3. So we get the limit as n approaches infinity of the absolute of xn less than 1/3. Although it's not going to matter because if we take the limit as n goes to infinity, this is never going to be true. Okay, so think about this. This is going to be the absolute value of x infinity, which is less than 1/3. Right, so now this is going to be what this is going to tell us. And of course, this is going to be infinity for all values except for one value. Okay, so this is infinity for all x except for x equals 0, right? Because we would have 0 times some number, and that would just go to 0 for us. Okay, and remember, we want to try to get a number that's less than 1/3. Okay, so the only value that's going to make this true for this particular problem is going to be x equals 0. So the interval of convergence is going to be from 0 to 0. Okay, or we could just write it in the step builder notation. We could say x such that x equals 0. Okay, either way you want to do it. Okay, that's fine. This is probably the way I think in my math lab that it wants you to do it. The radius of convergence, well, the distance from 0 to 0 is 0. So the radius of convergence for this one is r is equal to 0. Okay, so that's our interval and radius of convergence for this one. Okay, so this one was a really easy one compared to the previous because we didn't have to check the endpoints for that. Okay. All right, so hopefully in a couple more examples, we'll see that this happens on occasion, okay? But these aren't really all that useful for us, okay? We want to make sure that the radius of convergence can allow us to be able to do something with the series to be able to model some sort of transcendental function. All right, so we'll see a few more of these in subsequent videos.